Acha.
Gcse.
Very good. When we talk about titration, we need to know basically titration is one of the methods. One of the methods, right? In if you refer to our notes, it's method B. One of the methods of preparing soluble salts, right? One of the methods of preparing soluble salts from, so it's one of the methods of preparing soluble salt, but what's the difference? But it's different from method A as both the reactants in titration are soluble, which means what? Which means that titration is a reaction between acids and alkalis. You get it? Soluble, because metals are not soluble. Most of the carbonates are not soluble. So what is left is alkalis and soluble carbonates. All right? Is this clear? I want you to understand this first. So, but there is something that needs to be considered over here, right? In method A, we used to see that one of the ingredients used to become a residue. One of the ingredients used to stay in excess. So we used to filter it out, and what we used to have was a pure salt solution only, because acid used to get used up. Remember? You understand? So if you look at this in titration, what is it that we are able to see? Acid reacts acid reacts with soluble substances, right? Like sodium hydroxide, sodium carbonate. So no residue is seen. Do you understand? You cannot really judge. You cannot really judge whether all of the acid has,
Gcse.
you cannot really judge whether all of the acid has reacted, because you are not going to see any changes. In method A, we used to have excess metal, and when the reaction used to stop, we used to know that all of the acid has reacted with excess of metal. It means there is a lot more metal is present over there than the acid. So the acid will get used up completely. Here, it is very difficult to tell whether all of the acid is used up or not. You understand? So what do we do here? In titration, in order to tell, so how can we tell whether the acid has been completely used up or not? How to tell if the acid, has been completely used up? Because if we do not do this, if we do not make sure if whether all of the acid has been used up or not, when we move to the process of crystallization, we are going to not we are not going to get pure salt. We'll have a salt which also has it as with which is going to be a salt which has acid with it as well. Do you understand? So we have to make sure that all of the acid is completely used up first of all. So how are we going to do that in titration? We use indicators. We use indicators. All right. We use indicators to tell exactly how much alkali or soluble carbonate is required to neutralize the acid completely. Do you understand this? To neutralize the acid completely.
Gcse.
What does this mean? It means that we are also we are going to be having three things. We are going to be using an acid, an alkali, and an indicator, which is going to tell with these indicators they change the colors. They change in color. Once there is a change in color, we'll get to know that there is no more acid remaining. Acid has been used up, all of it. All right. So how does this work? It works. The indicators change color when the acid has been neutralized. What does that mean? The pH has become 7, or no more acid, or no more acid is there, or you can say all of the acid has become salt and water. All right, this is what it means. So this is titration. Okay, this is titration. So what are the main steps involved in it? You take, let's take, there is an acid plus an alkali. We are going to be using indicators to tell us whether all of the indicators are there. Indicator is there, that is going to tell us if all of the acid has converted into salt and water. So we are not going to be pouring any more alkali in it. This, you're going to get a salt solution. This salt solution can be, this salt solution is going to be formed into crystals, right? Salt crystals. What are the three processes that it has to go through? It has to be concentrated. It needs to be concentrate, formed into a concentrate, then crystallize and clean and filter. Remember the process of crystallization. All of these three things are actually the process of crystallization that we have done. Crystallization, right? Is this clear? Any queries?
No, sir. No, sir.
Basically, what takes place is we we have this setup. We use a stand. This is a stand. All right. On this stand, a white tile is placed. A white tile is placed. All right. A white tile is placed. This is called retort stand. This is called basically, this is called retort stand. It has clamps. It has clamps. Here it has clamps. These clamps, they hold the burette. They are going to hold the burette. And there are all these readings on the burette. They're going to hold the burette. And then we have a conical flask, flat bottom, conical flask that is placed here. In the burette we had acid. And in the conical flask, we add the alkali or the solution or carbonate, whatever you're using, with an indicator. With an indicator. So you gradually, you open it. So the color is already, let's say the color is already orange or something. You're going to drip this acid drop by drop and shake, drop by drop and shake, drop by drop and shake, until you see that the change in the indicator has occurred. You put a few drops, then you shake. You put few drops, then you shake. You put few drops, then you shake. You will all gradually see, you'll gradually see that the color gets lighter and lighter, lighter and lighter, because most of the alkali is being gradually converted into salt. You understand? Or you have to keep this in mind. Always, acid is always going to be in the burette. Burette, all right? Most of the time, it could be done either way, no problem. Burette, all right? It's supposed to be in burette. And this is in the conical flask. Conical flask. The white tile helps you to identify the color change, okay? We'll talk about this in great detail when we are going to be discussing the ATP paper and all. I want you to understand this first at the moment. Is this clear?
Yes, sir.
All right, all right.